This is Geometry Lessons 10.3 and 10.4. Volume of prisms, cylinders, pyramids, and cones. So these are pretty straightforward. Just a reminder what volume actually is. So volume is the space inside the 3D shape. Another way to think about it is how much it can hold. So if we're filling these up with a fluid, how much water could it use or hold, I should say. And then another way to think about it is if you were actually manufacturing these and they were solid, like completely made of metal, how much material would be needed to make this solid shape. Okay, that's your volume. In volume, we're always going to be multiplying three things together in terms of the units. And so these will always be to the third power, called cubic centimeters or cubic inches. And we'll see that here as we run through this. So very easy formula, volume equals the area of the base times the height. So big B is going to be the area of the base. And then this H, there's going to be multiple H's that we see. This is the height of the 3D shape. So when we find the area of the base, we are going to be talking about the height of that two-dimensional shape, whether it be a triangle, a square, trapezoid, whatever it is. This height here is different than that one. This is the height of the three-dimensional shape. So we'll see that as we run through here. All right, so these are very, very easy. Volume equals area of the base times the height. The way that I'd like to see you do it is to plug in the formula for the area of the base. It will differ depending on the problem. In this one, our basis of the prism here is a triangle. And so our formula for that is 1/2 base times height. And again, you'll notice this height right here is going to be different than the other one. So to try and not get confused, so I don't have to put another H next to it and then be like, wait, these look the same, but they're different. I'm going to go ahead and plug in for this height of the three-dimensional shape first. So we know that that's the distance between the bases. So base here, the distance between them is 11. So I'm going to go ahead and plug in 11 for the height of the 3D shape. And then I'll leave this little h here. This is the height of the base. So when we talk about the base, you can look at either this one or this one. Those are the bases. And so when we talk about the height here, 1/2 base times height, that's how we find the area of the base. So we're not looking at this 11. We're just looking at the two-dimensional triangle. What's the base and height of that triangle? So we know we have to look for a 90 degrees. Base and height always hit at 90 degrees. So 8 and 6 are going to be the base and height of this triangle. So it's going to be 1/2 times 8 times 6 times the height of the three-dimensional shape of 11. And you can just run that all the way through in your calculator, and you will get 264. And now for our units, we don't stress them a lot, but it is good to make note of what they should look like. We know for area, it's always squared. And so just in this little section here, we would have centimeters squared. And then we're timesing by another centimeter. The 11 represents centimeters. So it's actually centimeters times centimeters times centimeters. And so this is centimeters to the third power, which is pronounced cubic centimeters. All right, so again, what this actually means, we always want to make sure we understand not just how to get the right answer in terms of the number, but what it represents. This is how much water you could fit inside of it. If this was, say, a fish tank and you were filling it up, you could fit 264 cubic centimeters of water inside of it. Okay, to the next one. So we again have a prism here. Now, we don't have a practice one here, but this also works for cylinders. Okay, and the area of the base would just be the circles that are on the top and the bottom, and you would use pi r squared. We'll see a cone on the back, and it pretty much works the same way. So here we have a trapezoidal prism. So volume equals big B times H. Big B we're going to replace with the area of one of the bases, which is these trapezoids. All right, and that is 1/2 times the height times base 1 plus base 2. And now that's going to get times by the height of the three-dimensional shape, which is the distance between the two bases, which in this case is 14. So I'm going to go ahead and plug that right in so I don't get confused with the two different heights. Now just working with the trapezoid. So just looking at this two-dimensional shape that I've highlighted here in red, the height of that is this line right here, which is 4.8. So it's 1/2 times 4.8 times my bases added together. The bases are the parallel sides of a trapezoid. It's the top and the bottom here. So that's 8 on the top. I pulled that from here. 8, and then the bottom is 5 plus 5. Make sure you're adding those, not multiplying. Haven't done anything with the 14 out there yet. So I would add 8 and 5, times it by 4.8, and then I would take half. That comes out to 31.2 if you run those numbers in your calculator. Then you times it by the 14. You could do that all at once. That's perfectly fine. And that comes out to 436.8 cubic inches. All right, and then the last one on this side, we have a pentagon. So this is a pentagonal prism. We're going to plug in the formula for the area of the base. It's a regular pentagon, so that is 1/2 AP. Any regular shape, we can use that formula. And now the height of the three-dimensional shape is going to go out here. Remember, that's the distance from the base to the base. So the base is this pentagon on top. The other base is the pentagon on the bottom. How far apart are they? They are apart by 9. That's the connection between the bases. Now this one, there's no height actually in this other little formula, so it's not too confusing there, but it's still good practice to always replace that height right away so we don't have multiple h's in our equation. Okay, so we have all the information we need here except perimeter, so we'll figure that out here in a second, but the apothem is given to us, so it's 1/2 times 8.3. All the sides are 12, so perimeter is going to be 12 times 5. Which is 60. So we're going to go ahead and plug 60 in. And that all gets times by 9. So the apothem times the perimeter, take half. That comes out to 249. And I'm going to times that by the height of the three-dimensional shape of 9. So 249 represents the area of the base, the area of the pentagon in this case, times the height. Comes out to 2,241 cubic kilometers. Okay, to the back. So back here, we're still looking at volume. Now we're going to be looking at our pyramids and our cones. You'll notice the formula does look very similar. It just has a 1/3 in front of it. And the basic way, eventually you want to memorize these things. You won't have to for your test, but the basic way that I think about it is think of this like a cylinder. And if I extended this straight up like this, you can basically fit 3 cones. You can see there's 2 kind of upside down ones here. 3 cones inside of a cylinder, or if I did the same thing here, I could fit 3 pyramids inside of a prism. Okay, so we're basically finding the area of the full cylinder or the full prism, and then we're just taking 1/3 of it because it's 1/3 of the size. So for 1/3, we don't want to use the decimal version because it's 0.3 repeated. And if you just put 0.3 in your calculator, you're not going to get an exact answer. So you either want to use the fraction key and put in the 1/3, or multiplying by 1/3 is like dividing by 3. It just creates 1/3 of whatever you're looking for, which dividing by 3 will get you there as well. So that's what I would recommend. Get the full area with big B times H and then just divide by 3. That would be my recommendation. All right, so big B times H. Oh, and don't forget the 1/3 because we have a pyramid here. All right. I still think that the best way to go about this is to start by replacing big B with the formula of the base. So my base here, I only have one base in a pyramid and a cone, is a triangle. So it's going to be 1/2 base times height, and that's the height of the triangle, not the height of the three-dimensional shape. This H is the height of the three-dimensional shape, which here is 8. In a pyramid, it goes from the base to the apex, so that's 8. Now we can start plugging in. We're just looking at the two-dimensional base here. Remember, base and the height have to hit at 90 degrees. So it's 3 and 7 for my base and my height. 1/2 times 3 times 7. And I'm going to go ahead and do all of this at once. So let me show you how I would punch it in the calculator. So if you want to put the 1/2 in, you could as 0.5, or you could do the fraction. Times 3 times 7 times 8. That's 84.
Good morning.
And now that I've got this answer, to take 1/3, I'm going to divide by 3. And that is 28. Again, I've multiplied 3 times, so my units would be to the third power. This problem didn't give me units, so we're just going to leave it as 28. So you can do it any way you want. You could do 3 times 7 times 8 and then divide by 2 and then divide by 3. Or you could times it with using your fraction key, times 1/2, times 1/3. You figure out what works for you. All right, the next one. Pyramid, but the base is a trapezoid. Here's the base, it's upside down. So it's 1/3 big B times H. So big B, we're going to go ahead and plug in the area of a trapezoid. So 1/2 times H, B1 plus B2. And now the height of my three-dimensional shape looks a little confusing here, right? Because we got this 8 and the 10 and the 4, and they're all close to that line that represents the height. The 8 is measuring across the top here. The 4 is measuring across here. Those are the bases of the trapezoid. So 10 is the actual height of the three-dimensional shape. And so let's leave this alone for now. Inside here, it's going to be 1/2 times. Now, be careful. This height, we're just looking at the base, the two-dimensional trapezoid here. So the height of that base is 2. Base 1 plus base 2 is 8 and 4. So 8 plus 4. Make sure you're adding those bases, not multiplying. 10 is the height of the three-dimensional shape. I'm going to do this in just a couple pieces so we can make sure we understand how to compute these. First thing you should do is add those bases together. So 8 plus 4 is 12. And then you're going to times that by 2. Take half, so divide by 2. And that's 12. Okay, so I'm going to go ahead and just drop that in here. So I would do 12 times 10. That's 120. And then for 1/3, I'm going to divide by 3. And my final answer here is 40. All right, and then the last one here, a cone. So the base is a circle, still the same process. 1/3 area of the base times the height of the three-dimensional shape. So 1/3 area of the base here is pi r squared. The height of the shape is 24. So as always, just be careful with your radius and diameter. Make sure you're choosing the right one. 16 is the diameter all the way across. The radius would be half of that. So it's 8 squared. So we know that that's 64. So I have 64 pi times 24. So I would multiply 64 times 24 and then divide by 3. We're going to leave pi in our answer here. Always just check the directions. Sometimes they want you to have a rounded decimal, so then you would multiply by pi. We're going to do 64 times 24 and then divide by 3, and it's 512. And again, we did not put pi in, so we need to leave pi in our answer. The actual answer, like the real life number, you would have to times this by pi, and it actually represents this. So if you just put 512 as your answer, this is the actual answer, right? That decimal, 1,608. So if you just put 512, it's incorrect. It's not even close to the real answer. But if you leave pi in, it is the correct answer. So just always keep pi in your answer unless, again, the worksheet or whatever you're doing tells you to round to the nearest whatever. Then you would go ahead and multiply by pi to get your final answer.